Rachel, the Chem 360 SI leader. Today we'll be going over Williamson ether synthesis. An ether is an organic compound composed of two hydrocarbons connected by an oxygen. One of the most popular ways to form an ether is with the Williamson ether synthesis. In this reaction, you take an alkoxide and an alkyl halide and combine them together using an SN2 reaction like this, resulting in your ether. An important thing to note about the Williamson ether synthesis is that since it's an SN2 reaction, your alkyl halide must be a methyl or primary group, such as the one here. Knowing that your alkyl halide must be a methyl or primary group, you should be able to determine, given an ether formed by the Williamson ether synthesis, what your two reactants were. For example, if you have this compound, tert-butyl ethyl ether, you should be able to see that there are two options for your reactants. The first option is that the molecule could be split here, giving your reactants a tert-butyl halide and ethyl oxide. In this case, your halide is a tertiary group, which means that it wouldn't work for the Williamson ether synthesis. So then you have to look at your other option. If it didn't split here, it could split over here. That would give you reactants of tert-butyl oxide and an ethyl halide. In this case, your alkyl halide is a primary group, which means that it would work for the Williamson ether synthesis. Now it's your turn to try. If you're given this molecule, and it was formed by the Williamson ether synthesis, what were the two reactants that you started with? Pause the video here to work on it, then hit play to see the answer. Since we know that our alkyl halide reactant must be a methyl or primary group, using retrosynthetic analysis, we should be able to determine that the molecule splits here. That would give us these two reactants. Good job if you got it right. This has been the Williamson ether synthesis. Thanks.